Ohm's law tells us that V is equal to IR, and if we know two of these, then we can find the third. However, this assumes that we have a single resistor in our circuit, and we will want to work with a lot more complicated circuits than that. So we want to think about what happens when we have multiple resistors in one circuit. The first scenario we want to consider is the series circuit. That means we have two resistors connected to each other end to end. In this configuration, the current through the first resistor must be equal to the current through the second resistor. If they are not equal, a charge would start to build up, and that can't happen in a resistor because the like charges would all repel each other. I suppose we can use our analogy with a roller coaster. So if 10 cars are brought up the lift and then sent down the hill, then 10 cars will make it to the end of the track, assuming nothing disastrous happens. It's the same here. As long as it's operating normally, the current through the first and second resistors have to be the same. So we can use Ohm's law for each of the individual resistors. We know that the current through 1 and the current through 2 are the same, and the voltage drop over each resistor is the current I times the resistance. That means the voltage across 1 is the resistance of 1 times the current, and the voltage across 2 is the current times the resistance of resistor 2. So the total voltage is the voltage of 1 plus the voltage of 2, and that is the current times R1 plus the current times R2. So we can rearrange this to be V total is the current times, in parentheses, R1 plus R2. So the effective resistance is the sum of the two resistances, R1 plus R2. And if we have 3, 4, or 5 resistors all in series, we can do the same thing. We just add them up. So our total would be R1 plus R2 plus R3 plus R4 if we had 4 resistors in series. So for example here, we have two resistors with 100 ohms, and we put them in series. Then the total resistance is the sum of the two. So R1 plus R2 is 100 ohms plus 100 ohms. So that gives us 200 ohms for our resistors in series. Piece of cake. Okay, so the more complex configuration is when the resistors are in parallel. That means there are two paths for the current to travel, so it is very likely that the current through one is different than the current through the other. However, notice that the voltage drop across both, the voltage across resistor 1 and across resistor 2, must be the same, because they are connected by our no resistance wires on both sides, so that means that voltage has to be the same. So, using Ohm's law, we know that the current through 1 is the voltage divided by R1, and the current through 2 is the voltage divided by R2. So that means the total current I is equal to the voltage times 1 over R1 plus 1 over R2. That means that 1 divided by the total resistance is equal to 1 divided R1 plus 1 divided by R2. So this will require a little bit more algebra, but this allows us to solve for the resistance in parallel. Remember, in parallel we have split the flow of our current, so some of the current goes through one and some of the current goes through the other. You notice if we have two resistors, one is small and the other is large, then the two resistors in parallel will act just like the low resistance resistor, since all of the current will flow through the lower resistance resistor. Okay, so let's try a problem. So now we have two resistors in parallel with a resistance of 100 ohms. So that means that 1 over R total is equal to 1 over R1 plus 1 over R2. So if we plug that in, 1 over R total is 1 over 100 ohms plus 1 over 100 ohms. Here we have some algebra to do, so 1 over 100 plus 1 over 100 is 2 over 100, or 1 over 50. Since 1 over R is equal to 1 over 50, then R is equal to 50 ohms. So if we have our two resistors of 100 ohms in parallel, they will have a total resistance of 50 ohms. Notice that when you have two places for your current to flow through, the effective resistance decreases. So in the case of resistors in parallel, the resistance will decrease, and then if the resistors are in series, then the resistance will increase. Okay, so that's it for this week's lesson. So you have a few questions to finish off and a homework due on Monday, so good luck and take care of yourself.